I was listening to the ocean.
Your next exponential lesson is on rational exponents. Rational, hopefully we remember, is just a fancy word for fractions. So now, last lesson we did a bunch of exponent laws, all had whole numbers. Now we're going to have rational exponents, so fractions. Our learning goal, like last lesson, we're going to simplify using rational exponents. And I feel like maybe I didn't stress it enough last lesson. The first few lessons, at least these first two lessons anyway, the focus is more on the process than it is on the final answer, especially because some of you have calculators that spit that back, like spit the final answer back to you simplified, which technically wouldn't be allowed in class. So I do want to stress again, if I didn't last lesson, this is more about you using the laws and rules than it is about you using your calculator. You can certainly use your calculator to check your answer, but just like that first unit where a lot of you lost marks for not showing how, you need to make sure that you show how or explain why. This first thing is just a warm up. You don't have to copy this down. This is just kind of pattern building. So what I want you to do is I want you to type into your calculator the third root of 8 and then 8 to the 1/3 and see what you get. So I'll give you a moment. Now you might want to, just like last unit, you might want to get used to your calculator if you're not sure. And if you aren't sure, then make sure you send me a picture of your calculator and I can try to help you, or you can come on to Teams and I can help you with your calculator. Some of you might not have the button that looks like that. And if you don't, you might have a button that looks like this. You have to use that instead. And then for 8 to the 1/3, obviously you don't have an exponent button that's just specifically 1/3. So you're looking for the button that either looks like this on your calculator, which makes an exponent, or you're looking for maybe one like this, x to the y or y to the x. And when you enter that 1/3, make sure you enter it using your fraction button. And if you're still not sure about how to use your fraction button, you're going to want to enter it like 8 exponent button bracket 1 divided by 3 close bracket. So again, take a moment, try to figure out your calculator, type in both of those, just like you see it, and pause it. And when you come back, we'll take it up. If you did pause, welcome back. Hopefully you figured out your calculator. Again, if you have not, make sure you seek help from me. So let's start with our first one. The third root of 8. What did you get? Hopefully you got 2. What about this one? 8 to the 1/3. Whoa, we got 2. It's the exact same thing. If we're trying to draw some patterns, I know one example does not make a pattern, but if we're looking for things, what you should notice is that the 3 that was on the bottom of the fraction is in what's called the index of the radical. And radical, remember, is just a square root. And if you're wondering where the 1 went, what's really here? A 1. We just don't write it. And 1 doesn't change anything. What about the next one? What did you get when you did the 4th root of 81 cubed? Well, hopefully you got 27. What about 81 to the 3/4? Hopefully you also got 27. Same thing. These are the exact same calculations, just in different formats. One is written in radical notation or root notation. The other one's written in rational notation. Again, if we look at our pattern, where do we see the 4? We see the 4 on the bottom of the fraction. Where do we see the 3? Well, the 3 was our exponent. It was the numerator. So those are just some patterns to pick up on. And we'll officially write some things down in a little bit. Our first example, rewrite each as a radical and then evaluate. So if this is a test question, 1 mark for showing me the step, a 2nd mark for actually typing it into your calculator. Based off the patterns we just saw, the denominator, the 2, is going to go in the index. The numerator, which is the 1, is going to become our exponent. Now at this point, you may be looking at your calculator and thinking, I don't see a button that has a 2 there. That's because, so we'll do a little aside here. So this is just a little aside. That's because the standard square root has a 2 there. Since it's the standard square root, we don't write it. Just like we don't write a 1, it's just implied. So whenever you see a square root with nothing in the index spot, nothing inside that little v part of the square root sign, it's standard at 2, which really means, so again, this is standard, which means that an exponent of 1/2, so I'm just going to write x for any number, the exponent of 1/2 is a square root. Now continuing from that, going off on a bit of a tangent here, some of you may have wondered, why does a square root undo a squared? So for instance, if we had x squared, and we've had those in grade 10 and grade 11 during our quadratics, and you had to solve that, how do you solve that? Well, if we had x squared equals 9, let's say, what do? We square root it, or at least we've been told to square root it, and we've been told that square rooting undoes squaring something, and you're left with x equals plus or minus 3. But with this newfound knowledge, okay, let's really look at what's happening. It's x squared, and if we take the root has a fractional or rational exponent of 1/2. So really that's what we're doing when we take the square root. And now using the power law, what's 2 times 1/2? 2 times 1/2 is 1. X to the 1, just x. So that's why, if you've ever wondered why a square root cancels something, it's the opposite of squaring something. It's 1/2, whereas squaring something is squared. So what is our answer to this? Well, plus or minus 3. Try the next one. The denominator, again, our pattern, the denominator goes in the index. So the cube root of 216, and if you want to put the exponent 1 there, you can, right? That's the numerator, but putting anything to the exponent 1 is not going to change anything, right? Using your calculator, what is the cube root of 216? 6. Next one. Denominator goes in the index, so the third root of -1. And if you're wondering why, or if you're thinking, I know I can't do that because it's a negative, and I know I can't take the root of a negative number. I like where your head's at, but that's only been the case up until now because you've only really ever worked with just square roots, which is just 1/2. A cube root though, or something times itself twice, a cube root though is something times itself 3 times. And you can certainly do that for negative numbers because -1 times -1 times -1 is -1. So we're going to make a point of this. If the index is even, so if it's just a square root, which we know is 2 even though it's not written there, a 4, a 6, an 8, so on, can't do a negative. However, if in the index it's odd, so for instance, 3, 5, 7, 9, etc., it is possible. So you can square root a negative. So just pay attention to that as you're going through these. So what if the numerator isn't 1? Well, we're still going to use the exact same pattern that we've been using so far. So officially, excuse me, officially, the denominator goes in the index. So n root, our base, m, to the exponent m, whatever the numerator is. Or you could write it like this, and then in brackets, and then put the m on the outside. Or, so again, there's 3 ways you can do this due to order of operations. Or you can do this. So you can raise the a, the base, to the numerator first, and then do the denominator or the nth root. So we're going to rewrite as radicals first. Rewrite as radicals and then evaluate. So again, you have to show that you know what you're doing. The denominator, 3, goes in the index. Then my base of 8. And then this is completely up to you how you want to write it. You could write the squared on the outside, you could write the squared on the 8, or you could put that whole thing in brackets and square it. It's really up to you. It's the same thing. And how you enter it into your calculator, it's going to be the same answer, granted you know what you're doing on your calculator. So the cube root of 8 is 2, 2 squared is 4. Or you could have done 8 squared first. 8 squared, 64, cube root of 64, also 4, obviously. B, my denominator, which is the 5, goes in the index, then my base, and then numerator squared. Enter that in your calculator. 5th root of 32 is 2, 2 squared is 4. Same idea. The denominator goes in my index, and then my base, and then to the power of 4. The 3rd root of 125 is 5, 5 to the power of 4, 625. How do we think about that? Not too bad, hopefully. Just got to remember that one rule. And that's basically the basis of the rest of our lesson. For example 2, we are going to simplify using radicals. Now, because we have variables now, we have letters, it's not going to be a straight up just evaluate type of question. It's mainly on the simplifying. A, x to the 3/5. We've done some examples with this. That would be the 5th root of x cubed. B, now we have a negative exponent, so we have to recall some knowledge from the last lesson. What does a negative do? Well, it flips it. Flips it and makes the exponent positive. Now remember, this was really written over 1, any whole number is. So this is 1 over x to the positive 1/2. And we know 1/2 is our standard square root. So this is 1 over the root of x. C. Now you got to be careful with C. The exponent only is touching the a. It is not touching the 4. So that 2/3 only applies to the a, not the 4. And that's going to be a common mistake. You got to watch out for that. If the 4a was in brackets, then that'd be a different story. So 4, the 3rd root of a squared. And I might even write this in brackets just to drive the point home that that only applies to the a and not to the 4. Now, as you can see, D clearly shows you that that 2/3 does not only apply to the a, now it applies to the 4. It applies to everything in the brackets. So this is the 3rd root of 4a squared. Now you notice I wrote the squared in a different spot. I wrote the squared in a different spot because we can actually simplify this further, okay? 4 squared is 16, so this is actually the cube root of 16a squared. Whenever you can simplify, you should. Let's try another one. I'm going to throw another one in here. Let's try this. So I'm going to add e. Let's try 27a to the, let's say, to the 1/3, let's say. So because the 27a is in brackets, that 1/3 applies to everything. What does what does that do? That is the third root of 27a. And again, if you want to write the 1 here, you can. Now you shouldn't just stop there. You should always look whenever you're dealing with numbers. Can you get to an evaluation step? And you can. What is the cube root of 27? Well, the cube root of 27 is 3, right? Because 3 times 3 times 3, 3 times 3 is 9, times 3 is 27. So this is actually 3 and then the third root of a, because we can't do anything further with the a. So you always want to look out for those numbers to see if you can square them, cube them, square root them, cube root them, fourth root them, whatever. Get it as simple or small as possible, and 3 is definitely smaller than 27. It is going to take some practice to identify and work with these, so don't worry if you're kind of thinking it's a little bit intimidating at this point. Once you practice them, it's honestly not too bad. And you'll have all the laws in front of you to look at, to refer to. Example 3, we're going to do the opposite. Now we're going to simplify using exponents. Okay, well, just working backwards. My base is x. Whatever my index was, which in this case was 9, is going to be the denominator. Whatever this exponent was outside is the numerator. Simplify where you can. 3 over 9 is 1/3. So this is x to the 1/3. B, first thing you have to identify. The x, the variable, is on the bottom. That must mean it was negative because it was 1 over. And we know that I only get 1 over if it's a negative exponent. So step number 1, I would say, would be to realize it's x to some negative exponent. Now you just see a square root. Don't forget, a standard square root is really 2. So this is to the negative 2/3. C, this looks crazy. That's okay. It's not too bad. Start with your base. So this is a to the 6. And I'm going to cross things out as I use them. So a to the 6, used it. The next thing I encounter is a square root. Square root, we know by now, hopefully, is just a 1/2. So this is going to be to the exponent 1/2. Now on top of that, I have a cube root. And again, there's really a 1 there, so that's 1/3. So I'm going to do another set of brackets to the 1/3. Now let's simplify. This is just power of a power of a power law, which just means multiply your exponents. 6 times 1/2 is 3. 3 times 1/3 is 1. This is just simply a to the 1, which obviously is just a. Looked crazy. Wasn't actually too bad once we broke it down step by step. Start on the inside, work your way out. Still the same example, just kicking it up a little notch for each one of these. D, same thing. Start on the inside, work your way out. So let's start with our base. Our base is a to the 6, b to the 10. The next thing I encounter is the 8th root, which is really 1 over 8. The next thing I encounter is this exponent 1/2, right there. Power, power, power. You just multiply all your exponents. So a, now 6 times 1/8 times 1/2. You could use your calculator if you want, if you know how to use your fraction button. So 6 times 1/8 times 1/2, you get 3/8. Or if you don't know how to use your fraction button, 6 times 1 times 1 is 6, 8 times 2 is 16, it'd be 6 over 16, then you'd have to reduce that to 3 over 8. The same idea for B. 10 times 1/8 times 1/2, that's 10 over 16, which reduces to 5 over 8. So B to the 5/8. E. All right, so we're multiplying. That's okay. We'll still do it step by step. My base, my numerator, my denominator, times my base, my denominator, and my numerator. When you multiply like bases, going back to the last lesson, what do you do to the exponents? You add them. So really this is a to the 3/5 plus 2/4, which really is 1/2. From there, find a common denominator, blah, blah, blah. You should get a to the 11 over 10. Example 4, simplify and evaluate. So again, a mark or two for showing your steps, a mark for you punching it into your calculator. 8 to the negative 1/3. That's negative. Flips it. Becomes 1 over 8 to the positive 1/3. With our newfound knowledge, that is 1 over the cube root of 8. The cube root of 8 is 2, so that's 1 over 2. And again, you will only end up with plus or minuses for even roots. So if that was like the 4th root or 6th root or 8th root, then yes, it'd be plus or minus 1/2. Since it's the 3rd root, it can't be negative 2, it can't be plus or minus because negative 2 cubed is negative 8, and that's supposed to be positive 8. B is interesting. 2.5, that's not a fraction. You got to make it a fraction. What is 2.5 as a fraction? And I won't give you anything that's too crazy for you to figure out going from a decimal to a fraction. But 2.5, 2.5 is just 5 divided by 2. Now my denominator, 2, square root, right, 9, and then to the power of 5. The square root of 9, okay, is plus or minus 3. So this actually is plus or minus 3 to the power of 5. Which means you could technically get plus or minus 243. C, I see a negative. Okay, that instantly means flip it. 4 over 25. Then to the positive 3 over 2. Now that 2, the denominator, means square root. So there's different ways you can do this. You can square root both the denominator and the numerator. You can square root the whole thing. It really is up to you. So maybe I'll do it 2 different ways. So 2 means I square root, right? That exponent goes to everything inside, cubed, which would be plus or minus 2 over plus or minus 5 cubed, which would be plus or minus 2 cubed is 8, and 5 cubed is 125. Another way to do that at this point you could take the square root of the whole thing. It's the same thing as taking the square root of the numerator and denominator separately. And the square root of 4 over 25 is plus or minus 2 over 5 cubed, which would be plus or minus 8 over 125. That's it for this lesson. Basically, the whole thing was just adding another law to your laws from the last lesson. And then the next lesson that's coming up is a long one. It's a bit of a doozy. It's not hard, it's just a little bit longer. And you are working on worksheet 3.2 from your homework package. That's it for now. Take care. Thanks for listening.